Just to reiterate, when you see a 4 to 20 milliamp sensor, don't get bogged down by detail. Don't sweat the petty, pet the sweaty. These are extremely robust and actually very easy to use, even if you just want to interface it with an Arduino. All you got to do is add a voltage drop resistor, 250 ohms. We have whatever battery, doesn't matter, goes into the sensor itself. Then through here, whatever amperage is going through here will have a certain voltage drop. You got to size this so it's a maximum of 5 volts voltage drop. Then on the negative side goes to ground. On the positive side of the resistor here, as we can see, the positive side of the resistor goes to analog input 0, whichever one you want. And then this gets plugged into your confuser. Your confuser reads off the values. Easy peasy, lemon squeezy. Gentlemen, welcome back to the shop. Today I'm going to show you how to use 4 to 20 milliamp sensors with an Arduino. Previously we saw how to fabricable a remotely powered pressure transducer what outputs analog voltage. And we read that both with a multimeter and with the oscilloscope. Perfect, great for data logging. However, how are we going to do instrumentation that does not have analog voltage output but has current output without the need for obfuscation through technical minutiae to make ourselves feel smarter? It's actually quite simple. You see here on these 4 to 20 milliamp devices, there's only 2 pins. 2 pins can't be that complicated to hook up. So the difference between, oh well, this one's this one's a current device, current loop device as well. But the difference between analog voltage out, the 0 to or 0.5 volts to 5 volts, is that these are less susceptible to noise and also less susceptible for longer runs of instrumentation cable, less susceptible to voltage drop. So these are quite a bit more robust, but there's a little bit of fancy two-stepping we got to do in order to use that for the Arduino. Now bear with me, if memory serves, and most of the time, the vast majority of the time it does, what we'll do is we'll have a power supply here. We'll set her at 24 volts because I remember these numbers. And we have an Arduino microcontroller here. This will read, this has an analog to digital converter, and it can take up to 5 volts in. Then it reads that voltage, if it's 1 volt or 2, and it assigns a numerical value to it. So this can read between 5 and 0 volts. How are we going to get 20? If we put 24 volts directly into there, she's going to fry. So we have 2 pins on this guy. So we'll call this the measuring device, plus minus. And what we can do here, we want this between 0 and, no, we want this between 4 and 20 milliamps. So to get 20 milliamps, V equals IR. So that means 24 volts divided by X is equal to 20 milliamps. That means, I did that fucking wrong. 20 volts divided by 20 milliamps is 250 ohms. So what we do is we put in a resistor here, 250 ohms. Then what we do is we have the microcontroller read that voltage. How do we do that? Well, we connect this to an analog input, A0, and we connect this is negative, we connect this to the ground of the Arduino. Simple as that. Positive goes to pin 1, and then negative goes to a 250 ohm resistor. I don't have a 250 ohm resistor, so we just take 3 10 ohm resistors, gang them up in series to get our 250. These little booklets, godsend. Definitely an addition to the bag of tricks. Cheap and so useful. Okay, prior to us letting the smoke out of a $40 Arduino, we'll just do an idiot check here. So that's the drop resistor there. What we're going to do is monitor the voltage across that resistor, and that will tell us the voltage that the Arduino is going to see. And here we have a current meter, and we're going to see what the current is across that sensor at 0 psi. We're at 24 volts, and we are at just about 4 milliamps. So at 0 psi, there's the voltage that the Arduino is going to see, 0.9 volts. So we've got a stand-in here for a 24 volt truck battery or system, or a piece of gear or whatever. But the interesting thing is you could take two 9-volt batteries, sticking them together like Lego, gives you 18 volts, and you're still going to get the same reading. Check this out. I'm going to drop this down here. As long as we're within the range that the instrument is designed to work at, the sensor is designed to work at, we still get the same numbers. So we're going to pop her up to 80 psi. This is a 25 bar gauge, so 25 times 14.7, whatever that is. So we're at 7. And then if I turn the voltage up to 24 volts, we're at 12 volts there on the supply. We'll turn it up to 24 volts. Everything stays the same. So that's proof that even if you have kind of a nasty supply, this is even if it's a noisy, nasty supply and the voltage is all over the place, this instrument is still going to work. So it's great for automotive systems or equipment or whatever that's running off of an alternator. Alternators are very, very electrically noisy. This is robust enough to be able to handle that. And here we go. Of course, if we just wanted to measure this with a multimeter, all we would need to do is put this in series. So we break the connection from the 24 volt in. We break that connection, put a multimeter in there, and that would show us the current. Actually, I'll do that. We can do that. But if you're just measuring voltage, you have a voltage measuring device. That's what the Arduino analog to digital converter is. What we need to do is put in a 250 ohm resistor. No big deal, really, as long as you got that. This is going to have 24 volts in. This will have the 24 volts negative here. This will go to the Arduino ground negative, and this will go into analog 01 sensing pin. So we've opened up the Arduino IDE and analog in, serial out. What that's going to do is measure the analog voltage on a pin and then print that serially to the confuser here so that we can log it. Real simple. We just made a couple changes. Analog pin is A0, and then we have an integer value, sensor value equals 0, output value equals 0. It initializes the serial monitoring, so it will send signals out. Then we say, going through the actual loop, this just loops over and over and over. It goes sensor value equals analog read, and it reads the analog pin, that value. It takes the voltage and assigns it a value from 0 to 1023. And we say the output value is equal to the map of the sensor value, whatever value that was, from 100 to 1023, and that will change it over to 0 to 367 psi. How do we know it's 367? That's the top scale, 25 bar, and then 0, of course, is the bottom of the scale. This number here is a best guess. You can calculate it, but it's probably better because there's some non-linearity in the sensor at the bottom of the scale. It's better just to guess. You just sort of mess around. And here we go. Once it has that output value mapped, it says serial print PSI and then outputs the value. And it just delays for 2 milliseconds. Okay, we'll open up the serial monitor and we can see minus 21 psi. What the hell's going on? It's because we're not powering the loop. A lot of times you don't have a power supply. As I said, you could do 2 batteries, 9-volt batteries, backed by each. I'm going to use this, however. Tool battery. So 0 psi in the gauge. We're going to open the ball valve. We're coming right up. We're off by quite a bit because we actually have something more like 90 psi. So we need to make an adjustamente. Now, we are running into a bit of a problem because of the non-linearity of this sensor at the bottom of the scale, 0 psi. So what I've gone and done is measured with my nice big gauge, accurate gauge, what the pressure in the tank is at this very moment, 66 psi. We are going to apply that to the sensor and see what we get on the serial monitor. And what I've actually gone and done is I've added this serial print sensor equals sensor value. So that will tell us what this guy is actually reading here when it reads this analog read pin. It'll be that value from 0 to 1023. So let's have a peek at it now. It'll start collecting data. And we can see it's at right around 100. And then when we apply 66 psi, it's only showing 154. So let's get a couple data points and try and figure out what the hell is going on. So we've got 0 psi in the sensor now. We're going to put 110 psi in there. See what it pops up to. 190. So what we need to do then is just change the calibration of this thing. So we go 190 is 110. That should do it for us. 8.72 milliamps, showing 107, 108 psi. Okay, well, without getting too much into the pixie wrangling side of things, I'll give you the broad strokes. That is how you use a 4 to 20 milliamp sensor with an Arduino. That's how you interface it. What you do with the data coming out of that, how you treat it, that's up to you. One thing you can do is you can data log it. There's little modules and it'll save it to a comma value delineated. You can bring it into Excel. You can also do all sorts of stuff, min maxes. There's also, if you have a different program on your computer called processing, you can take the serial data from here and actually graph it out. That's a little bit beyond the scope of just simply getting this thing to chooch. What I wanted to show you was how to interface these analog, well, these current loop devices with common stuff that you might have around the shop so that you can actually use the thing. Super useful. I mean, $100, free 99 depending on where you work. You get these out of the scrap bin all the time. So that's how you do it. Thanks for watching. Keep your dick in a vise.